something called translations, which is the very first thing on the next page. Translations fit under this bigger category called a transformation. Which just means you're changing the position or the size of a figure or shape. So most of these are going to be triangles with a couple parallelograms mixed in. No circles for this. There's 3 types of transformations. One is that fancy word translation. Come back tomorrow for reflections. And then there's a 3rd type, rotation. But you don't need to know that till your high school self learns it in geometry. So your 7th grade self needs translations and reflections. It seems like math is full of a lot of fancy words because translation is just a fancy name for slide. So this triangle can slide wherever it wants, basically. So the bigger category is transformation, and under it, smaller categories, translation, reflection, rotation. So far, so good? So today's translation, it moves points the same distance and the same direction.
I was trying one of the other ones for, so what did you say?
Translations move points the same distance and the same direction. These are some sillier examples, like this shirt has a pattern on it called Argyle, where it basically takes this parallelogram and moves it around the shirt and you get a pattern out of it. So it's just sliding around. Or wrapping paper is full of patterns. Here's this triangle party hat. Slide it up here, same shape, different location. I was looking around. Allison has a pineapple that's sliding around her backpack. Same shape, different spots. Or Ellie's pattern on her leggings. Same shape, different spot. Or the flowers on Allie's backpack. So it happens in a lot of places. Here's another silly one. My aunt and uncle have kind of an older cabin, and they have this wallpaper across it that has these ducks. But any wallpaper is a pattern like this. This is my really bad duck drawing. So the same duck kind of just moves across the wall in this pattern. Same shape, different spot. It's not like its tail went one way and its head went the other way. So that shape moves the same place, the same distance, the same direction. Is that making a little sense? The third thing we need to know is this word called image. When they write figure, I always want to change it to shape. The shape you get after a transformation is the image. So you have the original and the image. Where did it move to? You always know which one is the image or where it moved to because they use this prime notation, which looks a lot like an apostrophe. So the original point or shape is just going to be named A, B, C, D, E, F, G. But when it slides to a new spot, the same distance, the same direction, now it's going to be called A prime. Pete, is Tate in 10th grade?
11.
Oh, shoot. Anybody have a 10th grade at their house? What's their name? Dylan. So Dylan taking geometry could come down here to Ellie's 7th grade class and know that this A was the original and this A prime was the image because of that little prime mark. It's like a math language. Where it moved to, it's that little prime mark. Preston.
So when you're like writing a shape or something and you have to go the same direction, how do you know what direction to go?
Oh, that's such a good question. It is going to tell me. Did everybody get a chance to write? Okay, so a couple things in this picture. First of all, we know right away which one is the original KRT and which one is the image because regular K has no prime mark and K prime does have the prime mark. And then Preston says, how do we know where to move it? So this one went 5 units right and 3 units down. You wouldn't actually write these red arrows, but this is kind of like how your pencil would trace across. So T went 5 right, 3 down. R went 5 right, 3 down. K went 5 right, 3 down. So the whole shape went the same distance and the same direction. Are you seeing that? Yeah? Okay, so let's try in that first box that you have. Oh, my points are even missing. What did I do? So it says K is 1, 4. Ooh, did you miss graphing?
No. I did.
So really, you could make this into a big XY chart, right? Which way is X? Say left or right. So I'm going over 1, and then, nope, over 1, Y to the sky, right? Over 1, up 4, now I have, okay, are you doing this? It's your first box. How am I going to find R? Pete?
Over 0 up 2.
Over 0, up 2. Here's R. How am I going to find T? Allison?
Four radius, 4, and then up 1.
You do have a straight edge probably in that blue bucket if you need one. This is going to be a triangle. And then they're telling us to go, doesn't it say right in your box? 4 left, 5 down. Yes? Does anybody need to do jumping jacks? Are you breathing?
Yes.
4 left, 5 down. Where should we start? Any point you want, because we're going to move them all 4 left and 5 down. So I kind of just drag my pencil. 1, 2, 3, 4. 1, 2, 3, 4, 5. This is my image. So now it's called T prime. It moved to a new spot. Now which one should I do?
Okay.
Sure, K. Same distance, same direction, 4 left. Five down. Now it's called K prime. Which one's left? R. 4 left. 5 down. Now it's called R prime. Still have your straight edge? Now the shape should look the same once it moved. So does it look the same to you? Kind of like the duck. The head didn't go one way and the tail didn't go the other way. The whole duck slid the same direction. Preston?
Could you just call them prime still if we move it another time?
That is such a good question. If you were going to move it again, you would actually have like a double prime. So let's say R was going to move down. Now I'm going to have 2 marks, which means it's moved 2 times. It could go on forever, but it doesn't usually go past 2. Second one, we have triangle ABC. Yes? How will I find A? Oh boy. Godiva, how will I find A?
0 and then up.
Nice job. Over none, up 6. Mason, how am I going to find B?
Up 1 to the right 1.
Good. Preston, how about C?
Left 2, up 3.
Thank you. Find your straight edge. Different looking triangle, right? They're telling us to move
8 right.
8 right, 4 up. Where should I start?
30.
39.
we're gonna move all of them 8 right, 4 up. Kind of drag your pencil along. Now it's called A prime once it moves spots. That's the image. Same direction for B prime. Same direction for C prime. Use your straight edge. Double check, does it look the same? We don't want a new triangle, we want it to look the same. Pete gives a thumbs up. Did you use the little prime marks? So Ellie can go home and show Dylan her notes and he'll know exactly which one was her original one and which one was the image. So far so good? The bottom two have the directions of write a rule, and the rule part is kind of specific. The rule part always starts with an XY. This is on the bottom left. Do you see it? And it's followed by an arrow, meaning we're sliding. And now we're going to tell the X to do something. So we have to know which one was the original. Drake, here's your choices. Was black the original or blue?
Blue.
The original.
Black.
Why?
I don't know.
Zach Hellstrom, do you know why?
Because it's more darker.
Savannah, do you know why?
Bro, laughing at them.
No. Addison? Allie? Why is the black one the original shape? Savannah?
Because you can see the little dashes next to it.
Yay, Savannah! Woo! The little dashes, she said, the prime marks mean that's where it moved to.
Literally laughing at those two.
So I'm just picking P. It wouldn't matter if I did Q or R because it's the same thing. My pencil would have, is this the right word? Drug left. And then my pencil would have dragged it. I don't think that's right. Up. So I'm about to tell X how to move mathematically. So what happened to all of the X numbers? How could I say left very mathematically? Negative or minus 5. So this is the rule for this particular translation. All of the X's slid left, which is minus or negative 5 boxes. So now my Y, what am I going to box my Y number to? How could I write up mathematically? Math is basically another language. I know someone, he teaches at Big Woods, he calls it Mathanese. It's really a language. So you're telling X numbers to go left 5 because the X numbers go left and right. And you're telling all the Y numbers to go up 3 because the Y's go up and down. Did you write an example of a rule? Everyone wrote this? Bottom right one, Drake. How do you know which is the original?
Little dashes. No. Or it doesn't have the little dashes.
Right, it does not have the little dashes, but you say prime. So Zach Hellstrom, which one's original, blue or black?
Blue. Sorry, black.
Black, right. The black one was the original one. The blue one has the prime, so this is the image where it moved to. Now I want to write a rule for this. All of the rules start with XY. And then it has that arrow, meaning we're sliding somewhere. Translation.
Does it have to be specific? Looks like you put the arrow.
I've only ever seen it left to right. But I guess it could be right. So now, if Zach said the black one is the original and we're moving to blue over here, what are we telling all of our X numbers to do? Savannah?
Move over.
How?
I don't know.
Pete? Thank you, Pete. If you're on the number line moving right, you're adding. Yes? Or do I just stand over here looking ridiculous? Exactly. Plus how many did we move? Drag your pencil. Pete, thanks for getting the hang of it. You then noticed all of the Y's went down, so mathematically we'd say do you have a rule written down in box 4?
Yeah.
We're not done yet because I know you don't understand it. Go back to box 2 with our triangle ABC. What does it start with?
A.
X, Y.
Oh, yeah.
What happens to our X, Y?
It does.
Slide somewhere.
Plus A.
Ooh, how'd you know that so fast?
That's right there.
It says what?
8 units, right?
Oh, right. I was just doing this over here and only Pete knew. Right. 8. Are you ready to rule?
Yes.
Oh, top right box. Top right box. Top right box. Some people are on the left. Which one's your right box? Oh.
Oh.
You are not allowed to have a weekend anymore. Forget what to do.
Listen, so much fun for that.
What's happening to my Y number?
Up 4.
How am I going to write up 4?
Plus 9.
So cold in here. Top left box, KRT. How does my rule start?
X1.
Okay, now I feel like we're getting somewhere. What's going to happen to XY?
It's going to something else. It's going to go that way.
Slide.
Where that way? Left. No, right.
All of my X's went
Down. Up, down.
X's.
-4.
X's can only go this way.
Left.
Left.
Minus.
Or no. Right.
Minus.
4.
What happened to all my Y numbers?
5.
-5.
Negative.
Minus, negative, same thing. Everybody has 4 rules now. So when there's a quiz question on Wednesday that say what's the rule, everyone knows where to look. It's really hard if Allison says, I can't remember the rule. It's really easy if I go point at her paper to find the rule. Or if her paper's blank, that's not helpful. Good news, hers is not blank. You have a rule written down. They all nodded their head that they wrote it down. So when they ask us on Wednesday, they're going to have it written down. Look at what this says. for these 8 questions. So what do you think the question's gonna look like?
A rule.
A rule, Allison, thank you so much. You will also need 4 graphs on graph paper. So we're probably back to folding it into fourths.